Hello, this lesson is area. Now, many of you will know the area formulas and have done area in other classes or other times in your life. And our focus for geometry, is really to be able to derive the formulas, which means how did they come to be? Why is it base times height for a rectangle? Why is a triangle's half base times height? So for your EQ today, your question is about finding a way to derive the area of the formula for a kite. So I already have the formula, but how does that come to be? So please make sure you can show it in writing and in a diagram and maybe a short explanation to the side of that. Okay, so what is area? So if we look at a shape, right, in a plane figure, and that means plane figure means two-dimensional, so it's something flat. It is the enclosed region, right, of that figure. So it doesn't have to be a polygon. So if we're looking here, we can see that this is kind of a funky shape, right? It has this is the outside, and it comes around here, dips down, has this beautiful curve, and then here, and then goes straight across. So that is its outline or perimeter. And the region enclosed, the area, is all this shaded lovely blue part. So when you take any figure, what you are doing is, when you find the area, is that you are dividing up into square units. So that's why when you do area, it is a unit square or square units. Okay, I'm trying to, there you go. Sorry. So you can see that each of these is a square, but not all of them are full squares. Like here's a full square. Oops, sorry, but over here is not. So it's only calculating this portion and not this white part. So for these that are not a polygon, there has to be an approximation. Right? But you're trying to organize the shape into squares. And that's what we are doing. Okay, so that's what we're doing when we find area. So it doesn't matter the shape, if it's a polygon or not, we're trying to divide it into squares. How many squares of a particular unit, centimeters, inches, feet, will fit into this region? And sometimes it may be a decimal, right? Clearly, these are not wholes or half, it's curved. Okay. So let's take a rectangle. So what is the area formula of a rectangle? So we know it is length times the width. It's generally the formula that most people use. Now, for this particular book and for us, we're going to do base times height. And the reason why it's going to be base times height, because when you say length, it's always the longest side, and base and height means a little bit different. I'm using my mouth, so it's taking me a little bit long today. All right, so if this is 6 and this is 4, right, what is the area? So what we are doing, and some of you are like, Miss Mendez, it's 64 centimeters squared, or squared centimeters. So what does that mean? That means you are literally cutting this shape into 1 by 1 centimeters. So this is 1 centimeter cube, or sorry, 1 centimeter square, right? This is another one, this is another one, this is another one. So you're dividing this whole base into 1 centimeter pieces. And then this way, you're dividing this height to 1 centimeter units. And doing this creates squares. Well, how many squares is that? Turns out to be 64. And that's where that formula comes from. When you talk about deriving a formula, that's where we get base times height. All right, so here, if we look at that, so what if I rotated it, right? And so then this, right, is now the bottom. So when you talk about the base and height, this is the base and this is the height. And for here, this is not the base and this is the height. So it really doesn't matter. The answer is going to be the same. But when you talk about length and width, this is the length, right? But the base and the height is a little bit more flexible in what we do. So this is why we use base times height for rectangles and all the shapes that we're going to deal with. Next shape. All right, parallelogram. So again, we're focusing not on the formula, but how we got that. So formula for a parallelogram is base times height. As you can see, this is the base. Again, we're still using B and H. So we are consistent through all our formulas. And the height must be perpendicular. So you must have that. And it could be over here. It could also be outside, but is the distance between a set of parallel sides. There you go. For here, right? It's this distance between these two parallel sides. And they're all the heights here. So how is this formula base times height? Where did it come from? How do we know it's this? How do we know it's not base plus height? So we are going to watch someone else's video because I thought the visual for it was very nice. So take a moment, we're going to watch it. All right, so I thought it was cooler to have another video than me try to figure it out. I was trying to figure out how to do it live, and camera angles too complicated. So you could see that what happened was that it comes from a rectangle that has the same height and the same base. Okay, let's see. All right. And then if you cut this triangle, right triangle, and put it over here, it would turn into this rectangle there. So that's why it is the same formula as a rectangle, base times height. Now in the video, they talked about, they didn't say anything, but the person wrote length times width. It really doesn't matter. I mean, I could put happy face, and this could be a star, then my formula would be happy face times star. Like I said, for us, for consistency's sake, we're going to use base times height. So our next shape is a triangle. So the base is all the way across. And the height is actually the altitude, perpendicular segment from the vertex to its opposite side. So when you're talking about area, make sure that the altitude you have here is related to this base that you're given both. So it's not this side, it's here. If you have this height, it's this base. If you're talking about this base, then it's that altitude or height. So again, where did the formula come from? Now there's actually several different ways to do a triangle. This is the one that I found. We're going to watch this video. Are we enjoying the music? They're pretty fun videos. Whoops. Okay. So again, the person had used length times width, but I'm using base times height. So when we talk about a triangle, we have three different types of triangles: right triangle, acute triangle, obtuse triangle. So for a right triangle, again, depending which side you use for the base, if you're using one leg, then the height is the other leg, because it is that perpendicular to the altitude. Here you have that nice right angle. For an acute angle, the height will be inside. Again, for whatever base that you choose, the height would be in the inside for acute triangles. For an obtuse, you can see here, now if we continue this line here, it's actually on the outside. Now, when you use the base, you're only using it from here to here. You do not use that dotted line. It is not part of the triangle, right? Because it's called base times height. The base is here. So again, acute, obtuse. For here, I wanted to show you that the base here is this side. So the height, the altitude that corresponds with it is here. So don't always necessarily think of base as bottom. Really depends on the information and the sides and the numbers that they give you. So always really look at your problem. All right, our next shape is a trapezoid. Now we know that a trapezoid is a quadrilateral with one set of parallel sides. And here they are. Then because of this, it has two bases. Again, the way that we are going to be using it is base 1 and base 2. This is just a subscript. It's on the bottom. So it's just saying, hey, there's one base, and hey, there's another base. This could be base 2, and this could be base 1. It's really arbitrary. Doesn't matter. Some videos and textbooks will say this is A and this is B. Before what we're doing, we're using B1 and B2. The height is the distance between the bases, again, perpendicular. So we could have put the height here, put the height here. It could also really be out here. So really always look at your diagram and see what is going on. So your height could also be here. All right. So here's another video. A little different just in the notation. Look up here. So it's just when the way they typed it is a little different, but hopefully you can see that is, trying to go backwards, it is the same as here, right? Okay. Let us watch this video. Now for trapezoid, I've seen several different ways to derive the formula. This is just one way that I chose to pick this one because it was short and still very clear.
To find the area of a trapezoid, we can use the formula area equals 1/2 h, the height of the trapezoid, times the quantity b1 plus b2, where the b's stand for the bases of our trapezoid. So here's our height, and here are the two bases, the top and the bottom, the parallel sides of the trapezoid. Now to derive this formula, we can take and break our trapezoid into triangles. If we find the individual areas of the two triangles, we can add those together to get the total area of the trapezoid. So here's our first area, 1/2 h times b1, the top base. The second triangle actually has the same height. So our formula for that area is 1/2 h times b2, the second base. Again, if we add these two areas together, we can get the total area of our trapezoid. Now, if we think back to the original formula, 1/2 h times the quantity b1 plus b2. If we take and distribute that 1/2 h through our quantity, we find that our formulas are actually the same. So there you have it, folks. The area of a trapezoid is found by taking the individual areas of the two triangles that create the trapezoid. To find the area.
So I really liked that video. I liked how the person did that and explained that. So the formula that they came up with is, like person said, identical. It is the same. All right, so just a couple notes about a trapezoid. In some countries, it's called a trapezium. So if you watch a different video or see it, or hear someone from a different country, they would call it a trapezium. It is the exact same shape as a trapezoid, just pronounced different. The other thing I wanted to say is that if your trapezoid is situated this way, where's the base and the height? Now remember, the bases are the parallel sides. So here is base 1. This would be base 2. Oops. And then your 9 is your height. So again, don't think of B means bottom, right? It could also be here, vertical. So you be really careful. And since we're here, why don't we just do this problem? And for me, for each of the formulas, I don't know if you've noticed, I put actually a subscript and told you what the formula is, because there's a lot of A's. There's a lot of area formulas that we're going to have. So I chose to write it that way so you would know which formula goes with what shape. Okay, base 1. And people tend to forget the half for trapezoid and triangle, or they put a half in for parallelogram. So really be clear on your different formulas. All right. So half of 9. And I'm not going to take half of 9. I could, but 9 is odd, even though it's 4.5. I'm going to do it this way. All right. So your half, you could take half of this and multiply it. You can multiply 9 times 28 and then take half of it. I'm going to do half of 28, which is 14. And then I'm going to multiply 9 times 14. That's 6, and 3 is 12. I hope that's right. Yes. Okay. Just wanted to double check myself. And don't forget our units, because this did give us units. Remember, it is meters squared. You can also write it as square meters, like this. But we tend to do this one on top, right? Trapezoid. All right, our next shape is a kite. We can see that it is a kite because it is a four-sided, sorry, I was going to say it's a four-sided quadrilateral, but it's a quadrilateral. And that two consecutive pairs, right, are congruent. Two consecutive pairs of consecutive sides are congruent. So these are congruent, but these are not congruent to each other. And the formula for this one is diagonal 1 times diagonal 2. And so it's the whole length of each of the diagonals. Now, it doesn't matter which one's which. This, you could say this is diagonal 1 if you wanted to, or this is diagonal 2. It does not matter because they're multiplied together. Now, for your EQ is to actually derive like how do they get that? So think about the different shapes that we know: triangles, rectangles, parallelograms, and see if you can figure out how they derive that. There's more than one answer. All right, so let's do a couple problems. So let's see, find the area. Well, here, that looks like a home plate. But I don't know what the formula of a pentagon is, but I know I can break this down into a rectangle and a triangle. And if I can find each of those pieces, then I can add them together. So this is 9, and I know I'm going to need the height of a triangle. So this whole thing from top to bottom is 10. From here to here is 6. So that means this part must be 4. So this rectangle is 9 times 6, which is 54. The triangle is half of 4 times 9. So that's half of 36. Don't forget the half. So that's 18. Oops. So 18, okay, I'm using my calculator just to double check. 18 plus 54, I'm going to have that as 72. Now, I don't have the unit, so I'm just going to leave it. If you want to write units squared, that's really up to you, but you don't need to, but you can. All right, so this one, find the area of the rectangle. Well, the area of a rectangle is base times height, but I don't have the base, but I do have the height. Ooh, I have one other piece of information. Perimeter equals 26. Well, what's the perimeter? It means all the way around. So I have this and this. I don't know that, and I don't know that. So I know all the way around, which for here is 16 plus 2b, b plus b. That's the perimeter, and it's going to equal 26. So if I can find b, I can find the area. So if I'm doing the math, I'm going to subtract 16. That's going to get me 10. Therefore, b is 5 inches. Okay. So the area of a rectangle base times height. So 5 times 8 is 40. And because they have words, units, inches squared. Please note that the perimeter was just inches. It is not squared. All right, find the area. All right, so what shape is that? Well, let's see, what do I know? It's a quadrilateral. These two are equal. These two are equal. That must be kite then. Okay. So the formula for a kite is half d1 times d2. So diagonal, this one all the way across. 6 plus 15 is 21. Again, it doesn't matter which diagonal you found first. This one is here, and that is 16. All right, so half of 16 is 8. So that is 168 centimeters squared. Okay. 2 more problems. Now let's see what this is. Find the height of the trapezoid. Okay, this is different. So, find the height of the trapezoid. So this one, okay. Well, I know the formula is half height times base 1 and base 2. Now, I was just thinking about it. Some people may have seen the formula written like this. And we should know that is the same. Identical. And just pull the half out in front. All right, so I know what the half is. I don't know what the height is. That's what I'm looking for. I know base 1 is 2. I know base 2 is 4. What else do I know? What's on this side? A. Oh, I do know the area. The area is 18. Okay. So now we're going to simplify that. 18. Okay. So it's half. 2 plus 4 is 6. So half of 6 is 3. So H is going to be 6. And because it's height, it's just units. All right, so let's look at this problem. Oh, I can see immediately Miss Mendoza forgot something. I did. It says find the base of the parallelogram, but I forgot to write what the area is. Okay, so why don't we just pick a number? Why don't we say the area is 96 inches squared. Huh. All right, so given the area, and it says find the base. So again, totally forgot to write this. So where did Miss Mendoza get it? She just got it from her head. She forgot to write it down earlier. My bad. So your base is here. So your formula is area equals base times height. I know the area is 96. So write the formula first and then substitute in what you have. So you're going to divide, right? 8 to both sides. Ooh. Therefore, the base is 12 inches. Okay. And there you are. So this is area. So please make sure you know the formulas, you have them written down, and then you also know where those formulas came from. All right. Thanks for watching. Bye.